This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software. This episode of SE Radio is exclusively sponsored by Linode. Linode makes cloud computing simple, affordable, and accessible. Whether you're working on a personal project or looking for someone to manage your company's infrastructure, Linode has the pricing, support, security, and scale you need. With Linode, you get consistent and predictable pricing across 11 global markets, 24/7 by 365 human support, rich documentation, and policies and controls to strengthen your overall security posture, allowing you to grow at your own pace. Users consistently rank Linode as one of the leading public cloud providers on both G2 and TrustRadius. Want to learn more about infrastructure as code and Terraform? Visit linode.com, that's LINODE/SE Radio, and download their ebook Understanding Terraform and other resources for free today.
Welcome to Software Engineering Radio. I'm your host, Jeff Doolittle. I'm excited to invite Luke Hoban as our guest on the show today for a conversation about infrastructure as code. Luke Hoban is the CTO at Pulumi, where he is reinventing how developers program the cloud. Prior to Pulumi, Luke held product and engineering roles at AWS and Microsoft. At Microsoft, Luke co-founded TypeScript, developed Go support for Visual Studio Code, and was part of the design teams for ECMAScript and C#. Luke is passionate about building tools and platforms to enable and empower developers and is a deep believer in the transformative potential of the cloud. Luke, welcome to Software Engineering Radio.
Thanks. It's great to be here.
We've had some shows in the past, and we'll reference some of the show notes that have talked about infrastructure as code. And just for listeners who maybe aren't familiar with the concept, first, we might use the phrase or the three-letter acronym IAC throughout the show to refer to infrastructure as code. But let's start with, from your perspective, a brief overview of what is IAC for listeners who are new to the concept, and also why does it matter?
Infrastructure as code is really the idea that we want to take the cloud infrastructure that we're managing and we want to encode it as code, not just as something where we point and click in a console and create some stuff in a sort of ad hoc fashion, but where we write down in text and in programming languages and in software and in code the way that we want our cloud infrastructure to run. And I really think about this as sort of bringing the notions of software engineering into the space of cloud infrastructure. And we've sort of seen how software engineering principles, practices, and tools have enabled us in lots of other areas to scale up the complexity of what we can build and manage and sort of get value out of. And we really want to do that same thing with the cloud as we want to build more and more complex things that have more and more value and get more and more benefit from what the cloud providers are offering to us. One of the core things we need to do is bring some of those software engineering tools to bear on that.
So what are some of those specific software engineering principles or practices that you would highlight as beneficial in this kind of an approach?
Yeah, so I think some of the traditional ones, when folks think about just infrastructure as code as it's traditionally been, even from the kind of Chef and Puppet and Ansible era to the sort of Terraform and Pulumi and CloudFormation and that sort of thing, I think folks often think about the first piece being, hey, I can take my description of what I want my infrastructure to be, and I can write that down in text. I can put that in a file. I can put that file in source control. So you start to get some of these basic things where I can describe my desired state, describe what I want, instead of me having to just describe a set of steps for where to click in a console or something like that. I can write it down in a format that I can version and I can version control. That's where infrastructure as code, I think, really started. And tons of value you get just from sort of that aspect, right? That's seen a huge, rise in the complexity of what folks have been able to manage. But I think really when I think about it, I kind of joined the infrastructure as code movement, I'd say kind of after that phase had already been well established. And now we're sort of looking more at what are the other places where we can bring software engineering benefits in. And there, I think it's a whole bunch of additional things like, hey, what about versioning and packaging? What about testing? What about, the ability to build reusable components? This is something that software is really great at, right? We can, instead of reinventing the wheel every time, we can kind of go and solve a problem, give it a name, give that function a name, give that class a name, put that in a package, reuse that from NuGet or NPM or something. How do we componentize? How do we create abstractions? Then how do we get IDE benefits so that we can sort of productively work with the platform? How do we get all these other things that software engineering gives us? How do we bring all that into scaling up what we can do with cloud infrastructure? And so for me, that's what IAC really is all about.
Yeah, so you covered a bunch of things there, many of which we'll get to in the show. And when you started out, I kind of sensed a distinction there between basically a declarative approach versus an imperative approach. The imperative is you're literally saying, provision this resource if we're talking about infrastructure, versus declaring is there is a resource or there will be such a resource. And it seems like that's one of the distinctions that you're drawing, at least where things have moved in the IAC movement. And then that's interesting too that you related it to making it work with existing developer tools there at the end as sort of a way to leverage maybe the knowledge that software teams already have as they're adopting these kinds of approaches.
Yeah, I think both of those are great points. And on the first one there about kind of declarative versus imperative, one of the interesting things with IAC generally is I often think of it as really the core thing that IAC is fundamentally is a desired state thing. And I don't think about that purely as being about declarative or imperative. It's more that the thing I'm describing is the desired state of the environment. And that's particularly important because unlike a normal, piece of software that I might write where I sort of run it and it ends at some point and maybe the process dies or something and I start it up again. With infrastructure as code and cloud infrastructure, it's there forever. If I say I want to have an S3 bucket, well, that S3 bucket's going to be there forever.
Effectively.
Yeah. My infrastructure programs are things that describe the desired state. And when I make changes to those, it's actually sort of changing the program that's running the whole time, right? And so it's sort of this interestingly different model for kind of how I think about it. And the fundamental part of that, I think, is that what you're doing is you're describing what's the desired state I want now. And when I make changes to that desired state, how do I get from where I am to that desired state? And then I think kind of in front of that, the feel of the experience of authoring infrastructure as code, I think there's some tools that really lean on a very, very declarative model. They sort of invent a DSL or they use JSON or YAML or something like that to have a very declarative feeling interface to that desired state model. But I think tools like what we work on at Pulumi, things like CDK that AWS is working on, they actually provide an imperative experience for users where they can sort of use a lot more of this richness, software engineering capabilities and software-based capabilities. But they're still defining the desired state. They're just using higher level primitives to kind of do that in more expressive languages. And so I think, for me, I think that whole spectrum of different ways that users might interact with infrastructure as code is really interesting. But at the end of the day, I think the defining characteristic there is, hey, but it's a desired state model. I'm describing what state I want my infrastructure to be in, and the underlying IAC tool is going to move my cloud infrastructure into that state.
That's a great clarification. And I'm glad you mentioned the concept of desired state because I've heard that as well, kind of in this realm, that's really what we want. And that'd be great if we could just do that into the world as well, right? Into the universe. Here's my desired state and it just happens. But, I guess we're still working on that. We've seen some of how it matters, right? I mean, you mentioned other things like reuse, componentization, these kinds of things, which is all great stuff that we all really want to be able to benefit from, not having to reinvent the wheel all the time. So listeners are going to be all over the place. Some are going to be doing existing applications and some are going to be building new applications. But give us a sense of if somebody's interested in exploring this space, where would they get started?
The great thing about IAC is there's, a ton of different on-ramps, right? Everything from hey, let's imagine that you've got a whole bunch of existing infrastructure that you have just kind of point and click. You've gone in the console, you had to get a project up and running as quickly as possible. So you clicked a few times, you created your bucket, you created your web app, whatever it was. And now you're kind of realizing, oh, well, I don't exactly know what I'm managing here. I don't exactly know how to reliably recreate this environment because I want a test environment that matches this. Like, how am I going to go and create that? And so it's probably around that point that you're realizing, this is where I kind of need infrastructure as code, or I need some way to describe what I've got, to repeatably recreate it, to understand when and how to make changes to it, that sort of thing. There's a few things. One, there's a lot of ways to go and export what you've got inside these cloud environments. Tools like Pulumi, a lot of the other IAC tools have ways to sort of import existing infrastructure into the tool. Pulumi has a Pulumi import command. Similar things in a lot of other IAC tools where you can kind of go and take existing things you've built and sort of bring them into that IAC environment and start managing them with your IAC, even if they didn't start off in life managed by an IAC tool. There's also a lot of folks who they take the approach more of, hey, I've got my existing stuff, which I'm going to leave alone. I know what state that's in, but I've got this new stuff I'm going to build, or I'm extending my application to have some new components. Maybe I'm adding in a new service, or I'm adding a new capability, new caching layer or something like that. That new project, I'm going to kind of use IAC from the beginning, but I'm going to reference some of that existing infrastructure. Typically, a lot of these IAC tools offer a lot of different ways to discover existing infrastructure, bind into that, and kind of use it from the new piece that you're building using these tools. The key thing is really that just learning how to use the IAC tools. And I think, for Pulumi, we've got, Pulumi.com getting started. You can go there, you can go through a really quick, 5 minutes. You'll kind of have a simple application stood up in your cloud environment. And then you can go through that process of, hey, how do I use this tool to map to my problems, not just these sort of generic problems. If you've got any amount of sort of software engineering kind of background, I think these tools tend to be, pretty easy to pick up. Really, as with everything in the cloud, a lot of the complexity comes down to just all the value, all the concepts that you've got in that cloud environment, all the tools you've got available to you to pick up off the ground and leverage. And that's where you can use the ISC tools to help you explore and discover and sort of tame that.
Yeah, and that's great to hear that listeners can get started. Haven't we all? You use whatever portal's available to you from the vendor, and then after a while you say, this isn't very sustainable. I've seen teams where, okay, I have to remember pushing the buttons in the same order in production as we go live that I pushed them in dev and in test, and the odds of you getting it right are actually quite low. And the more complex the system is, the likelihood plummets. So the ability to adopt these things with existing systems seems really helpful. Now, there's also more movement towards command line interface, which I'm a big fan of. I like the command line and being able to drop down to the command line, but maybe distinguish a little bit as well there between, I've got the pretty GUI with Azure or Google Cloud or AWS, and then I've got the command line, which is pretty powerful. But next thing you know, I'm writing bash scripts to automate my command line. So talk a little bit there about too, maybe where's the line? I guess what I'm saying is I feel like the line is clear for me between the GUI and some kind of automation, but the CLIs can sort the command line interfaces. They can kind of give you the sense of, well, I am doing infrastructure as code, but maybe distinguish those for a little bit when you'd say, no, it's really time to graduate from just using the CLI and start using an ISC tool.
That's a great point. There are really several different steps here. I think there is the sort of UI driven thing where you're just kind of pointing and clicking around. Then there is the bash scripts or the PowerShell scripts or whatever it is like that is just, shelling out to AWS CLI commands or something like that.
Right.
One of the troubles that kind of scripting based approach runs into is just that it is very fundamentally imperative in the sense that I'm bashing on the cloud APIs, right?
Bashing. I see what you did there. Yes.
I'm going to do this. I'm going to do this. I'm going to do this. And the problem is, well, what happens if my environment ends up in a slightly different state, or if I make a change to how those scripts work and I need to handle the fact that I had an already provisioned environment, I don't get to just provision my environment from scratch every time. It's that notion of, hey, can I move from one state to another reliably is something that tools that are built around sort of the scripting kind of solutions tend to not handle well. And that leads to fragility. It leads to, especially fragility in the cases where, hey, there's some operational issue and I've got to get some change out, but my script doesn't quite handle that approach yet. And so now I'm rushing to fix my scripts in the middle of an operational.
It's always the worst time.
Exactly. Yeah. That was early cloud and sort of pre-cloud VM-based era. There was a lot of that where folks, the majority of what folks did in kind of infrastructure management was these kind of scripting approaches. And that's still very, very common. But we find for almost everyone who's managing anything with a meaningful amount of complexity to it, and that's practically anyone trying to really use the cloud today, they find that those kind of tools don't scale super well, and that they do need to have something that's a bit more kind of desired state focused, that is able to take an existing piece of infrastructure, move it into the state they want. That's a key distinction I think we see. There's always going to be little bits of this scripting, just any those operational tasks, all sorts of things that are going to need to sort of be imperative actions that you take. And you're always going to have a little bit of that around the edges. But we find that folks, the more that they can pull into sort of IAC tools, the more confident they feel about what they're managing in the cloud.
So really, at the end of the day, that's going to come down to managing the complexity, which, as you point out, as soon as you go cloud, you're introducing orders of magnitude of additional complexity, unless you just run a single VM, in which case it's really barely the cloud. And then you have to consider maybe poking away at the GUI is good for exploring what's available. But when it comes down to managing routers and VPNs and compute and storage and buses and all this stuff, then it starts to get pretty daunting pretty quickly. And I imagine one of the things ISCs are trying to do too is create some amount of consistency. If every team has their own custom YAML or TOML file or JSON or whatever, and their own custom scripts, that also adds complexity that's hard to maintain and a burden of training. And the person who wrote it leaves and nobody knows what it does. So I imagine that's also something that ISC tools are trying to help with as well.
Absolutely. It's one of the interesting things I remember seeing kind of when I came into this specific, I came from a background working on developer tools, mostly for application developers and kind of programming languages and IDEs and developer tools and that sort of thing. And coming into the cloud infrastructure space, is kind of amazed how much of what gets done is copy pasting stuff around, right? If you went to an application development team and they said, oh yeah, we solved that problem by copy pasting a couple hundred lines of code from this code base over to this code base, like everyone would laugh you out of the room, right? You're not allowed to do that if you're an application developer, right? You gotta,
People do it, but yes, they
people do it.
shouldn't. Yeah.
It's not the standard. The standard is, I'm gonna make a reusable library. I'm gonna find something on npm that accomplishes this task. I'm gonna use that instead of reinventing that wheel or copy pasting it out of that code base. We have lots of great tools available to us for how to do this. And so that notion of reuse, of abstraction is sort of so deep in what we think about for application development. And still, that's not in the cloud infrastructure space. We do see a lot of copy pasting. Here's this 300 lines of code I wrote in a YAML file over here. I'm just going to copy paste that and put it over here as well. That's good the first time, maybe, but the 100th time, now you've made a change over here. All these things are diverging. Instead of having 100 lines of code you're managing, you've got 10,000 lines of code you're managing. And it just creates a ton of risk and complexity and management overhead. And so that's where we sort of see, hey, like these are things we know how to solve. We know how to bring kind of software engineering tools in. We know how to bring programming languages, IDEs, packaging, those kind of things in to help with these problems and to give folks the ability to kind of manage those problems as they scale up.
It's great. So you referenced before kind of almost like there's two phases, maybe it's not two, but some kind of like there's this sort of early phase, early stage, Chef, Puppet, Ansible, which are still around. And then there's what you kind of referred to as this second maybe phase, Pulumi, Terraform. So maybe tell us a little bit about what distinguishes sort of those two timeframes in your mind, and then also what kind of distinguishes, say, a Pulumi from a Terraform and those other players in this space as well.
Great question. And maybe I'll split it actually into sort of my view on kind of three phases of this in a sense.
Great.
I think, the first one is sort of pre-cloud or early cloud, where really most folks were managing, think of it as sort of VM-based architectures, right? Mm-hmm. Where they were managing a couple of VMs. Typically, they knew, it was very much the pets, not the cattle.
Correct.
Knew what those VMs were. The work of the team managing that application was to run the right software inside that VM. And they were just responsible for all that. They wanted to make sure they did that reliably and repeatably. So they were using IAC. They were using things like Chef and Puppet to sort of orchestrate how they deployed things inside that VM. But it was all about code running inside a virtual machine. Right. And fairly simple topologies outside of the virtual machine. Maybe there's a database in a single VM or a couple of VMs, but generally a pretty simple infrastructure outside of that that's mainly managed imperatively through, VMware or something like that.
Sure.
That was sort of the first phase where IAC started to become a thing. I think then there was sort of the early cloud phase where a lot of those patterns moved into the cloud and there was more API-driven capabilities inside the cloud providers. And so the networking and compute and everything could be provisioned via API. And so now you sort of had Terraform and CloudFormation and ARM and things like that come about as ways to put desired state in front of all these new pieces of the system that were programmable. But still, the level of complexity of what folks were building there was typically not that high, right? It was typically maybe I've got tens of things I'm managing. I've got my VM, I've got my auto-scaling group and some networking pieces, but I've got a fairly discrete set of things. I don't change that often. I can be pretty intentional and sort of slow in a sense with how I manage these. I'd say with the phase we're kind of going into now that a lot of organizations who are really leaning into the cloud are going into, and I think really everyone is going to be heading towards, is what I sort of think of as modern cloud. And that's sort of the containers, Kubernetes, serverless, these modern technologies that have been built to not just be in the cloud, but sort of be native to the cloud. And it's not just lift and shift my VM architecture into the cloud and get some API-driven capabilities. It's, hey, I take a totally different approach to the architecture of how I build and deliver my software to take advantage of what the cloud provides. And the interesting thing with those architectures is they tend to lean a lot more heavily on me composing a bunch of managed services, either managed compute services like with serverless or managed data services or managed sort of fully baked services, whether it's like ML services or something like that. And what happens there is that a lot of the complexity ends up moving from, I no longer have to manage it. I no longer have to run that VM myself and put the software in that thing myself and manage that. And so some of that complexity that I had to manage before goes away, and that's an operational burden off of me, and that lets me move a lot faster and get to market quicker. Where the burden moves, though, is actually into the edges between all those services, right? The way that I connect S3 to EC2 to Lambda to Redshift. A lot of the complexity is now in how do I compose all of these pieces of value I've got in the cloud? And it's that complexity that is what IAC is all about. It's about how do I connect all these things, right? Mm-hmm. About what cloud IAC is about, what things like Pulumi are about. And so for me, that's the really interesting place where we're kind of going to is we're actually benefiting a ton from all these managed services, from all these modern cloud technologies. And it's net reducing the complexity of what we build a lot by taking all this operational burden off us. But the one place where it's sort of pushing some of that additional complexity is into the configuration of how all these things are connected together. And so that's causing the need for more and more sort of infrastructure and more scale in the infrastructure as code management. That's where we see folks looking for tools like Pulumi is, hey, I'm just realizing that to build this modern cloud solution, I need to manage hundreds, thousands, tens of thousands of cloud resources. I need those to be versioning and changing every day or every few hours. This is a software problem. This is not just an infrastructure problem. This is a software problem, and we have to figure out software tools to solve it.
No, that's good perspective. And you mentioned complexity. It reminds me of Larry Tesler's law of conservation of complexity, which we'll reference in the show notes, which is basically says you never get rid of complexity. You just move it around and hide it, right? And the reason, say, your car is easy to use is because all the complexity is behind the dashboard and under the hood. And in a similar fashion, right? We're not getting rid of it, but we see it shifting and moving into places that now need to be addressed in different ways.
I think the great thing also is this complexity isn't coming out of nowhere in a sense. It's coming because folks are getting more and more value out of the cloud.
Yeah.
These building blocks are so valuable, right? They're letting them deliver more quickly, deliver more reliably, deliver more securely. So folks want to go and take advantage of all this stuff. But the one cost of that as they extract that value and as they try to extract more and more value is just that there is more complexity. There is more stuff that they've got to connect up together.
Absolutely. Maybe talk a little bit now about what distinguishes those. We talked kind of about the history and sort of where things have been and where they're going. So what distinguishes maybe the different vendors in this space of how they approach IAC? What do they emphasize? Different tooling, things of that nature.
The one probably most consistent thing for anything that sort of thinks of itself as an IAC tool is this notion of kind of having a desired state model and describing the state of the world. And so then within that, I think there's some of the traditional tools that were really focused on largely in-guest provisioning and OS provisioning and that kind of thing. Then there's sort of another set that's really focused on cloud management. So managing cloud APIs and the configuration of different cloud services. And so I think that's one place where there's some differentiation. You've got your Chef and Puppets on one side, and you've got your Terraforms and CloudFormations and ARMs on the other side. Within that second camp of kind of managing the cloud, I then think there's one big category that's sort of about is the interface to that. We talked about this earlier. Is the interface to that a declarative model or kind of a software-based model? And there's a set of tools like CloudFormation and ARM, obviously using JSON and YAML as kind of a way to describe that. Fairly limited domain-specific languages, really meant to be about more treating the infrastructure as data than treating it as software in a sense. And that's good at small scales, but that maybe is more difficult at very large scales. And then you've got tools like Terraform, which have their own domain-specific language. It's not quite JSON and YAML. It's a bit more expressive than that, but it's also not quite as expressive as traditional kind of application development languages. And then tools like Pulumi that I work on and the AWS CDK. These are tools that let you use existing programming languages that you may already be familiar with, TypeScript, Python, Go, .NET, and use those environments to manage the desired state of your infrastructure. And so for a lot of application developers, both folks who already have or understand that their scale is such that they need these tools to manage complexity, or they have that background of working in one of those software ecosystems and they want to continue to leverage the test tools and the packaging tools and the componentization tools and IDE tooling that they're used to. Those tools can be great for them. So those are sort of some of the big categories that I think kind of differentiate some of the existing tools.
Yeah, and back to what you mentioned before about adopting good software engineering principles here with that approach you're kind of mentioning at the end, seems like it fits better in a productive developer flow where, well, we send in pull requests and we do code reviews and we test these things and we do security audits on them. It seems like that approach can maybe kind of dovetail. That's kind of the point, right?
Yeah, I think a lot of teams already have good software engineering practices around their .NET code bases and their TypeScript code bases and what have you. The things you were just talking about, the pull request workflows and that sort of thing, but also the testing, the continuous integration. They have a package manager somewhere. Maybe it's Artifactory or something like that.
Sure.
They have all these things set up to kind of manage their software for their application side. With this class of tools that kind of Pulumi's in, you can kind of go and reuse all those, and teams are more likely to go and sort of reuse those and say, hey, I think I should be testing my infrastructure because I know how to test using the tools I've got available to me in C#. How can I apply that now to my infrastructure because I'm doing that in C# as well?
Yeah. Well, from there, let's segue then into, okay, I've decided to adopt IAC, whether it's a brand new system or an existing system that I'm going to kind of do side by side or convert, whatever it might be. So now if I'm adopting this approach of code that represents the desired state of my infrastructure. What are the ways people manage these definitions? It's one thing to say, well, you write code. Okay, you write code, but are there distinctions maybe between standard engineering practices? Are there also similarities? How do people start to think through, okay, I'm going to do this. How do I organize and maintain this set of descriptions of desired state?
It starts in the same way that a lot of application development might start. That, hey, I might start with a very simple program where I've just got kind of one code base. It's got all the logic for what I want to build out. But over time, I might realize that there's some pieces of this that are actually reusable components. And that's actually easier for me to understand what I'm doing here if I take this subset of my application code, factor it out, give it a name, give it a nice interface. And now it's easier for folks to both understand and test and validate that piece, but also to more easily understand what the kind of full application is doing, because it's now framed in terms of higher level building blocks that have been put together. And so I think the same sort of thing really happens with infrastructure as code, where teams will generally start by just kind of building out their infrastructure, writing it down as code in kind of just a flat format. As it grows, as they evolve, as they understand where the sort of versioning boundaries are, where the sort of abstractions are in what they're building, when they stand up their third kind of microservice or something, they realize, oh, well, a microservice is actually this set of 5 things, right? So maybe I should give that notion a name. And now I can sort of make improvements across all of those pieces if I do it in one place. And so we see that sort of a lot of that same evolutionary path in terms of how do I manage that code base tends to happen. And folks who kind of come into these problems with a bit of an engineering mindset tend to be able to apply those tools and tend to be looking for those opportunities to sort of simplify and modularize and componentize the applications. So I think that's one aspect of it, is sort of the code management and how a code base evolves. Mm-hmm. That's one that's really important. And maybe we'll talk more about it later, but bringing in some of these other tools like testing and like package management, those sorts of things, as it gets more and more complex, we have ways to really lock in the behavior of different pieces of this and version the behavior of pieces of our infrastructure.
Yeah, now it's infrastructure as compiled packages that you deliver, which we will definitely get more into as we go. But speaking of that sort of thing, if I'm doing infrastructure as code and say I'm in an environment like in Java, I'm using Maven, in .NET, I'm using NuGet, I'm in TypeScript, I'm using NPM, whatever it might be. Am I typically using just what a vendor that I've chosen is given me, or am I also leveraging other existing packages out there to help sort of add to what I can do with IAC?
Yeah, I think that's one of the really exciting things. I think, the sort of answer is both, but I think it's also something that I think is shifting more and more now. With these IAC tools, you have access to the raw building blocks that the cloud providers provide, mm-hmm. right? So sort of everything available in AWS, everything available in Azure, everything available in Cloudflare. You kind of have the raw API that the cloud providers, so you can do everything, but those tend to be low-level building blocks, right? Mm-hmm. And for a lot of folks going and figuring out again from first principles, how do I connect, all these different pieces I need together? There's a lot of people reinventing the wheel on how to build a best practices VPC in AWS, right? And so then there's sort of libraries that can be built on top of that, which are that best practices VPC. Hey, I don't need to go and put together those 15 building blocks myself every time. I can just go and use this higher level building block that has built into it with some coarse grained parameterization. Right. Here's a way to sort of get the most common patterns for how to configure a best practices VPC as documented by AWS. And now I can, for most purposes, for the common 90% case, I can just use that and write a few lines of code and I get all the infrastructure I need. And so those kind of libraries, whether it's libraries that, you build as an end user or is it for your organization to capture your best practices, or whether it's part of something that's available in the open source or from a vendor as part of a higher level library they create, I think that's a place where we're seeing more and more of that reusable infrastructure libraries being built out now. I'd say it's still relatively early for that, but I think there's going to be a lot of progress there just as the complexity folks are trying to manage keeps going up. Yeah. We're going to see that continue to be an area where that ecosystem grows, and something we're doing a lot of work to try and kind of build out that ecosystem around kind of the Pulumi model, but it's something that, we're also plugging into all the other existing ecosystems, whether it's Helm charts or CloudFormation templates or ARM templates or other things where there might be ecosystems of reusable components of infrastructure.
That could go to some really interesting stuff. And we'll talk future more at the end, but I got a bunch of synapses firing right now thinking about, well, I want a template that's going to let me run my system with these components. What happens if I run it on, Postgres with SQS? And what happens if I run it over here with, Mongo and Azure Service Bus or whatever? Just like, I don't know, run both. what do they cost? How do they benchmark? How do they this? And it seems like that's the sort of thing we might even be moving more into as we can automate these things and define them in more consistent, templatized kinds of ways, which could be really, really interesting.
You kind of took it even one step further there, which I think is a few interesting ways that I think are really interesting. They're sort of building reusable libraries that just take a single pattern on a single cloud provider and give it a name. But there's a lot of patterns that can make sense across multiple cloud providers, right? Some of the basic run a Postgres database and a Linux VM. Hey, we can run that on any cloud. So maybe we can build that, component as an interface that I can sort of develop to. And now I can instantiate that on any cloud provider, right? Because the differences between the cloud providers, while there might be some performance differences and those kind of things, just like I can run Java or .NET on a variety of different platforms, I can, in theory, run my cloud application on a variety of different platforms. And so that abstraction capability also starts to get into kind of how can we think about multi-cloud and that sort of thing.
Visit linode.com/SERadio and see why Linode has been voted the top infrastructure as a service provider by both G2 and Trust Radius. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Linode offers the industry's best price-to-performance value for all compute instances, including shared, dedicated, high-memory, GPUs, and their upcoming bare metal release. Linode makes cloud computing simple, affordable, and accessible, allowing you to focus on your customers, not your infrastructure. Want to learn more about infrastructure as code and Terraform? Visit linode.com, that's LINODE/SERadio, and download their ebook, Understanding Terraform, and other resources for free today.
So I've adopted IAC. We've got a repository. We've got our definitions in there. We're starting to get this thing going. And now I need to actually apply these definitions. So talk a little bit about that aspect of IAC. I imagine maybe at first there's some manual aspects to it. Maybe you then can begin to automate some of these things, try to move towards full automation. And in that context too, I'm very curious to know about the fact that engineers don't ask, how can we make this thing work? Engineers ask, what's going to break? What's going to go wrong? Mm-hmm. So when we're talking about applying these things like monitoring, fault tolerance, recovery are going to be really important as well. So give us kind of a flavor of, I want to adopt this. I'm starting to learn it, but now I need to actually do this stuff out in the wild. And how am I going to do that effectively?
A few different layers on this. And I think a lot of what I'll talk about is sort of true for most infrastructure as code tools. So the last step maybe is something that we're doing some interesting work on with Pulumi, I think. But the first step is really, I've written some new desired state and I want to deploy that. I want to say, hey, I want to make that desired state be my real state that I've got in the cloud provider. And I'm going to do that, using a CLI command, for example. I'm going to run, AWS CloudFormation, deploy, what have you. And I'm just going to say whatever code I've got, I want to make that the truth, right? So that kind of CLI-based workflow is really the starting point that most folks use for getting started with infrastructure as code, is that I'm going to use a CLI to deploy that infrastructure. And I'm going to sort of interactively understand what the state of that deployment is. And I'm going to see sort of the status of what's deploying. I'm going to, if something goes wrong to your point, I'm going to understand that sort of synchronously during the deployment because I'm watching that CLI output. And I'm going to go and take some corrective action based on what that error message is or whatever. I'm going to fix up my desired state if it was actually an invalid desired state. And so that's why it failed. I'm going to fix it up and then rerun that deployment and move to that new fixed up state, what have you. And so I think that's where a lot of folks start. That's where IAC traditionally has kind of been focused. That's a good starting point. What teams working in production environments want, though, is they don't want to rely on some operator sitting at their machine running commands that are modifying the cloud, right? They want to move that into shared processes that are typically a sort of continuous delivery process or something like that, where changes to infrastructure are pushed through kind of a delivery pipeline, like they're driven by a Git process where they're going to push that code into a particular branch, and there's going to be PR, and the PR is going to show a preview of what changes might get made to the cloud provider, and someone's going to review that and say, yes, I accept, and this is okay to deploy. And now when we deploy that, we're going to sort of see that process through a continuous delivery pipeline. And so that's one of the great things. We can take all of that, those same tools that we used on our desktop, we can move those into a CI/CD kind of environment and take advantage of all that sort of continuous delivery infrastructure that we've got, but use it not just for application delivery, but for delivery of changes to our infrastructure itself. So that's where we see, most serious IAC users today are kind of doing that. They're putting their IAC tools into continuous delivery. The last step is one that we've been working on at Pulumi, something that we call Automation API. And this is a thing that we actually saw was a lot of the teams we're working with who really are sort of software teams trying to manage cloud infrastructure. They were looking to go beyond just CI/CD and kind of build their own custom software solutions that managed the delivery of infrastructure changes. So where they could really deeply customize what steps happened in between different parts of the cloud infrastructure changes. They could author that as software. They could version that as software. And so Automation API was sort of a way to embed the deployment of cloud infrastructure into your own software solutions. That could be, hey, I'm building my own sort of self-service provisioning portal where users can come up and say, I want an instance of this thing. And so that's going to go and kick off a deployment of that thing, or I want to change this configuration setting or whatever. And they can build that application as a piece of software, and it's going to drive a whole bunch of infrastructure delivery processes on the back end. I see that being kind of a next wave of like how we drive infrastructure delivery is going to be these sort of custom software solutions that folks build that aren't just a CI/CD workflow, but are even more to the metal automated solutions. And we've seen a ton of folks doing really interesting things with that Automation API. And I think that's something we're going to see in a lot of other places. We also see variants of that in the Kubernetes space with sort of the operator models and that sort of thing, where folks find really interesting extensibility models into Kubernetes that are kind of based around some of the same ideas of software-driven automation of infrastructure changes. And so that's a trend that's sort of more nascent, but is going to be really interesting over the next few years.
And really that triggers for me even a bigger concept of maybe listeners are familiar with some of the workflow engines that are out there. Like I know Netflix has Conductor, there's Apache Airflow. And speaking of monitoring, fault tolerance, recovery, these kinds of things, and this is the first time I've thought of those tools in this kind of a context, because typically I'm thinking of those in terms of a workflow for a business process for a customer that we're trying to build software for. But it seems like you could take that automation API as you're describing it. Maybe it already does some of these things, or maybe it needs that bigger kind of workflow engine. But now that ability to say, yes, I have my desired state, but steps could happen that go wrong and need to retry or need to whatever it might be. And how do you see that stuff kind of playing out as well and taking this kind of even workflow automation for these sorts of things?
There's both those sort of more generic workflow solutions, the kind of things you mentioned that, as you say, are mostly about kind of business processes, that sort of thing. I'd say there's a set of these that are kind of being developed over the last couple of years in the market that are more focused on DevOps kind of scenarios, things like Puppet Relay, things like something called Filament is doing some interesting stuff there. There's a set of technologies I've seen kind of being developed that do try to apply some of the same ideas, but into some of the specific nuances of kind of the DevOps workflows and automating those things. And a lot of the times, things like infrastructure as code deployments are steps in those workflows. But to your point, there's a more complex workflow that needs to be managed on top of that. And supporting those kind of tools is one of the scenarios for things like Automation API. But I think those take that another step further, where they build sort of declarative processes on top of how we manage that. And I'm not sure exactly where that class of things will go. I think that's also reasonably early. But I do think capturing as many of these processes in software of some kind is something that's just a trend that, is always going to be there, right? If we can capture workflow processes in repeatable software-based solutions, that's going to help us to scale those processes.
For sure.
And that's something that's true across every industry.
Some things, it depends on the nature of your business, the nature of your use case. Some things are always going to be easier and some things are always going to be harder depending on what you're doing. And one of the difficulties, I think, as we start moving more into some of the depth, I think, of testing and things of this nature with IAC, what's really nice to be able to do is to basically stand up a near production environment with, and I'll call it production quality data. You might have to sanitize PII or personally identified information, these kinds of things. But also, that's tricky. If you're Uber, you don't get to do that because you have way too much data to do that. But can IAC help if maybe I'm not Uber, and most of our listeners aren't, with that kind of thing where I can actually say, I want to hit a full production environment with production quality data. And when I confirm it, flip that over and kind of a blue-green deployment sort of an approach.
Yeah, I think there's a whole bunch of sort of different patterns there that are interesting, but I do think that sort of IAC solutions generally can be a big part of it. I think one of the first things along that path is just, hey, the ability to even create another copy of my environment, right? And if I've written down the description of what my infrastructure is, I at least have some hope that I can, recreate it, right? Whether that's just to create a one-off staging environment that I can use, or whether that's to every developer can stand up their own version of the environment. Or, some of the things that, we do this internally for some of our stuff, but we've seen a lot of our customers do interesting things around this where every PR that they open is going to stand up a whole new copy of the infrastructure. And that copy is going to go away when the PR is closed, right? But that, that could be either the whole infrastructure, it could be a subset infrastructure, but they use infrastructure as code as a way to describe what is that thing I'm going to stand up a copy of on every one of these instantiations, and I'm going to parameterize that via some settings that maybe the user can control, but at least I have that repeatable process where I can go and stand this up and tear it down. As soon as you have that ability to stand up your infrastructure again, that opens up so many interesting possibilities.
Yeah, it does.
It opens up staging environments. It opens up per developer environments. It opens up these sort of review apps kind of style PR things. It opens up testing abilities. Now my tests can stand up an environment, run a bunch of tests against it, and tear it down instead of having to test against a production environment. But I think, to your point, it's not just the infrastructure there, right? It's how do I get the data seeded into that thing? How do I get, there's a few other things I might need to do to sort of get that environment to really represent something production-like enough so that I can sort of validate what I need to validate.
Right.
And I think that's where one of the interesting things with some of the more modern infrastructure as code tools is they really give a lot of flexibility for how you intertwine kind of management of infrastructure with taking specific actions. And so if you need to run database migrations or do seeding of your database, you need to sort of intertwine some actions into that deployment. There's a lot of tools to sort of reach out of the kind of pure desired state model and into, hey, I'm going to write some custom code here that goes and runs a command against, I just stood up my SQL instance in the cloud, and now I'm going to run some commands to sort of imperatively put some data into that thing to seed it or to pull that data over from some other environment where I already did that data cleaning or whatever. So I think a lot of these IAC tools, even though their primary focus is around managing cloud infrastructure, there's a lot of ways to go and break out of that and sort of run some custom logic that can help you to define the pieces of your environment that aren't just managed by cloud APIs.
Now, let's say I create a desired state definition, and let's say I have two environments running and they're actually different for whatever reason. Set aside the arbitrary nature of my setup here, but I'm curious, when I've defined this, is a tool like Pulumi or Terraform, is it creating a diff of my desired state versus actual state? Or do I have to actually make sure that whatever desired state I'm defining is already pegged to a particular, sort of like database migrations? I can define a new database and then the migrations are going to be specific to the state of the actual database. But it's nice if I can just declare the state I want and say, well, database A is a little different than database B, but the tool just figures out the right migrations for both. How do the tools kind of help with that sort of thing, the IAC tools?
Yeah, in general, a lot of these tools have the ability that they do keep track of what state the environment is in, just because it's typically expensive to try and recover all of that state from the cloud providers. So they manage their own view, and so then they can compute, hey, this is the delta I need to apply.
Right.
They typically have options for refreshing that data, pulling that data out of the cloud provider, and understanding what that drift is between what's the desired state that I understood the world to be in based on the last time I did deployment, and what's the actual state of the world. Mm-hmm. And so we can then go see that diff, see what has changed, and then decide whether we want to kind of drive that back into the desired state that I'm managing, or else I can make changes to my desired state to say, no, that was an intentional change. My desired state is just wrong. Maybe somebody went in and said, I want 4 instances instead of 2, and I haven't yet changed my desired state. And I don't want to undo that. I want to actually just represent that back in my state. And so then they can go make that change. And now when they do that refresh, it won't say there's a diff and everything will be okay. Right. So there is that process of sort of reconciling those two things, understanding when drift has happened, and then sort of taking action to correct that either in the real state or in the desired state.
Well, I think that's a good segue to talk some about security in the infrastructure as code world. In an ideal world, nobody can touch your database. Your migrations are pristine and they're always working against the state you expect. In the real world, somebody can get an SA password and bypass all that. Somebody can go to your AWS portal and spin up a new instance of something or mess with things. There's a couple aspects to security here as well. I mean, I guess one of them is security around who can create the definitions, but I think that's pretty straightforward, standard software engineering practices. But I think more interesting is, how do you check the security of the infrastructure that you're wanting to stand up? That's one. And then also dealing with compliance. Who can deploy what infrastructure? Somebody says, I want a K8s cluster that's the biggest K8s cluster that's ever been built, and it's going to cost $1 million an hour. Okay, we got to deal with that too. So security, kind of like, how am I deploying secure cloud systems, and how can IAC help with that? And then also security around, you can't do that.
Yeah, I mean, so obviously an interesting balance in a bunch of directions, because security piece is really important, but then there's also that everyone wants to provide the sort of developer velocity, and how do we empower folks to have as much capability as they should have, but without having any of the capability they shouldn't have.
That's right.
So, and that's a tight balance, because sometimes those are really conflicting.
It's like parenting. Things. Give your kids all the freedom they can handle and no more.
Yeah. It's exactly sort of the same content. I'd say a couple of things. One that I think is a starting point for me for this is just the cloud providers have just an amazing set of capabilities built in around security and managing security. That's really the starting point, is understanding, taking advantage of all the primitives that are available at various different levels to manage security, whether it's at the IAM level, whether it's at the sort of network protection level, whether it's at the account level. There's a whole bunch of layers of sort of, you can apply different security practices that are typically built into these cloud APIs at a pretty deep level, and they have incredible building blocks to work from there. So the first answer is sort of the infrastructure as code just lets you use all those building blocks, right? And so a lot of what you're doing when you're kind of managing security practices via infrastructure as code aren't necessarily specific to the infrastructure as code tool. They're just about, taking advantage of all those primitives and taking advantage of all those building blocks you can use to bake those security practices into the infrastructure patterns you're using. I think as part of that, that tends to be, we talked earlier about creating best practices, reusable components. Well, of course, those best practices, reusable components have security best practices in them as well, right? So I can capture those best practices once. I can then have everyone in my organization use the same thing. If I realize that there's some hardening I want to do around that component, I can do it in one place and everyone else benefits from it. Mm-hmm. The same sort of things that help with sort of application security, right? Where I can actually rely on the building block I'm building on top of is secure by design. And so now I get all those benefits from it. That's really the core thing. There are some things at the infrastructure as code layer that I think are really interesting around security. And there's sort of two pieces that I think of. One is, we kind of talked about the automation piece and moving from, hey, a developer is on their machine just going and running some command. And the environment you've got is that the developer just is copy pasting some production credentials onto the machine and then running a command. Eventually you're going to run into some problems, right? And the security of your deployment is going to have some issues. And so folks typically are doing that where they're creating continuous delivery pipelines or something like that, where there's privileged agents capable of doing deployments into the production environment. But there are a whole bunch of checks in place, whether it's manual gating approvals or code reviews or what have you, that are going to make sure that only things which are kind of approved, have been validated, have been run a preview, that we know what kind of changes this is going to make. And so the review has gotten a chance to see that ahead of time. Right. But there's a bunch of process and sort of validation in the same way that, hey, if I'm building a mobile app and I want to deploy that out to the world, I'm going to put a whole bunch of gates in place to make sure that only a build that actually works and that has been validated and it doesn't have some Trojan horse built into it. I'm going to put all these checks inside to make sure that that's a good thing. The same thing we can do kind of in our continuous delivery, and infrastructure as code really works very well inside those environments to help me understand those previews, help me understand what changes are being made, that sort of thing. And then I think say the last piece is policy. And that's something that a lot of the infrastructure as code tools offer. We offer it for Pulumi, kind of have a way of describing policy associated with infrastructure. So things that have to be true about my infrastructure for it to deploy correctly. And so I can have my compliance team or my security team build out a set of policies that are going to apply to any infrastructure I deploy, or maybe any infrastructure that's going to deploy into my production environment, and say, hey, like, you cannot open up a new public IP address in this VPC or something like that without getting an approval for that, or you cannot make a S3 bucket public or that sort of thing. And so we can put this policy in place, and now these tools will enforce that policy on any deployments that happen using environment. With Pulumi, for example, we can actually use software to describe our policy as well, right? So we can build reusable policy abstractions. We can build arbitrarily sort of rich ways of doing that. Maybe for cost, for example, I can go pull down the AWS price sheet. I can go compute the cost of everything. And I can say, hey, your cost increased by, when I tried to deploy this giant Kubernetes cluster, your cost increased by $1 million an hour. So you probably don't want to deploy this, right? Put a big red mark in my deployment that's going through that continuous delivery pipeline and just warn that reviewer that, hey, you probably shouldn't accept this because it's going to increase your costs.
And then calculating that before you ran it, is he right? Which I think is kind of what you're
exactly
saying.
What you can do, right? You can see that during that preview. The reviewer, before they merge that into production, can see that and they can say, no, we have to make this change before we go and deploy that. So those are the sorts of things I think you can do. And there's a ton more richness that can be built with the kind of modern compliance policy tools that are available now.
Absolutely. And speaking of that, maybe a bit of a side note, but are vendors like Pulumi or others, are they sort of reinventing policy, or is there potential for adoption of, you mentioned cloud native before, and of course there's the CNCF, Cloud Native Computing Foundation, which leads me to think of something called Open Policy Agent. So is there an ability to use existing tools in the ecosystem to apply policies within an IAC context?
Yeah. So I think there's a whole bunch of different answers for different vendors.
Yeah, I know. We don't want to go too deep into that. It's a little orthogonal, but I thought it was at least interesting in the subject of compliance to talk about a little bit.
Open Policy Agent obviously has been growing really fast over the last couple of years here, and especially in kind of the Kubernetes space, but really expanding to a lot of other spaces as well. With our Pulumi policy solution, we let you write those policies in the existing languages that we have, like TypeScript and Python and things, but we also let you write it in Open Policy Agent, which is sort of has its own language.
Yeah, Rego, which I can put a link to in the show notes.
Exactly. Yep. So it lets you kind of write Rego-based rules and then use Open Policy Agent as the execution engine for those rules. But instead of enforcing that policy against the Kubernetes manifest, you can enforce that against a Pulumi deployment. I think there's a lot of interesting stuff going on in this space, and I think all the vendors, but certainly Pulumi, really trying to integrate into and let folks bring places where there is a lot of innovation happening. Let's bring that in and let folks use that with our infrastructure as code tools. But the core thing is we want to make it so that you can plug that policy solution into the Pulumi execution of your cloud infrastructure deployments, whether that's using TypeScript or Python or using Rego.
I actually think that's a great story because options is a good thing to have. People need options. Like, we mentioned before that using the GUI to stand up cloud infrastructure, it's not right, wrong, good, bad. It's different. And there's a context for it.
Yep.
It becomes bad when the complexity becomes unmaintainable or it's too easy to break it. And that's when it's time. So in a similar fashion, I think it's great that there's options here. You can use the language you're familiar with, but you might have, and I think this is coming, we're going to have more and more people who are super familiar with OPA and Rego. And that's going to become possibly a specialization all of its own. And to be able to leverage that asset, that resource, that knowledge, and plug that into this whole IAC pipeline, I think has a lot of promise. So that's really cool to hear that that's an option even already.
Yeah, it's an option now, but I think it's something that's going to be, I agree with you. I think it's going to be an even bigger thing as we move forward. And as this specialization does grow even larger around not authoring the infrastructure, but authoring the policy around the infrastructure, because there's a ton of richness in that space as well.
So now from that kind of big scale discussion, right? How do I manage all this infrastructure and all the policies and compliance and the costs and everything? Now let's bring it down to I'm a developer and I'm doing IAC and I want to be able to test. And for me, and I know for a lot of our listeners as well, it's important to try it as much as you can to be able to run things locally. When the Wi-Fi dies, if I can't get to my cloud provider and I can't develop, that is a bad situation to be in. So from the spectrum of fully isolated testing in my own environment using IAC, to maybe some integration testing with cloud resources because I want to check how things are going to work with near production type provisioned resources. Tell us a little bit about the testing landscape with IAC kind of along that spectrum.
When you're doing application development, you largely want that to be as isolated as it can be from any of its dependencies in a sense, right? And so you want to be able to run that application locally. You want to be able to sort of do that inner loop of development on that, iterate really quickly inside the application code base. For that piece, you want to have the local database that you can use instead of having to go out to the cloud, whatever it is you do for your application development. IAC typically doesn't have as much of a role there because obviously you're trying to keep everything locally. Where testing really starts to impact IAC is in a few different places. So one is, once you do have cloud infrastructure that you're managing as part of your solution, well, you want to make sure that infrastructure does what it says it does, right? And so you want to be able to validate things or validate that things are true about that infrastructure. And so I think of that as sort of unit testing your infrastructure, where you write, hey, you've got your infrastructure description over here, but now I'm going to write some things I believe need to be true about the results of that infrastructure. So especially as I build more and more complex components that describe infrastructure, I want to say, well, if I'm building this best practices VPC component and I say I want 3 subnets, well, let's let me make sure that there really were 3 subnets created. Right? Let me really make sure that they have non-overlapping CIDR ranges, right?
I think I'm in my desired state, but am I really?
Yeah. But a lot of this is things that I can just say, I don't even have to deploy my infrastructure. I can just validate that my desired state program describes something that has this to be true. And so I think that unit testing piece is just me writing down all the sort of contracts of what things need to be true and just validating that. That can be very fast. It can be validated as just as part of unit testing my infrastructure without having to deploy it. I think then sort of validating things are true when I deploy, that's where actually a lot of the policy tools we just talked about can come in, because they can validate things as I'm deploying infrastructure, or even when I'm previewing deploying infrastructure. I can say, well, I need to validate that this is true, and I want to fail immediately if something is not true, because that indicates I'm outside of the sort of state I want it to be in, and I want to go and take some remediation action. And so I think policy tools can sort of be part of a testing solution at that layer as well. And then the last, which I sort of think of as the most interesting, is sort of the integration testing. And that's where kind of being able to stand up environments or subsets of environments from scratch is really interesting, where to test some components, if I can go and just create a production-like environment, then run all of my application level tests against that, but where the environment is real, right? I'm actually using real cloud infrastructure. I'm using the real network topology I'm going to run in. I'm using the real, a database that is configured exactly the same as my production database, just maybe with different data inside it. Mm-hmm. That can give me a whole bunch of confidence that not just my application is correct, but the infrastructure that I'm wanting to run my application in. And especially as increasingly we're having to change both our application code and our infrastructure kind of in lockstep. We're making changes to, we've got a serverless application, maybe we're adding in some new data service that's going to trigger a serverless function. And so the code I need to write and the data service that I'm connecting to are kind of being co-developed. And so now I really want to, when I want to test that, I really want to be able to stand up a copy of that environment, validate that not just the code does what it says it does, but that it does what it needs to do relative to the data source that's going to trigger it. And so, yes, that is something that I can't just validate entirely on my machine, but it's something that's essential to my application. And I need to test it. And if I can make it so that whole environment is something I can stand up really quickly, run my tests against and tear down, now that opens up so many possibilities for me creating, much more confidence. Now, when I open up that PR, I can run this battery of tests to validate that the application and the infrastructure work correctly together. I can get that green check mark. And now I feel confident that when I merge it into production, it's going to work correctly. Yeah. That category of testing is really where infrastructure as code tends to unlock really fundamentally new things that give me significantly more confidence in my deployments.
And then what about auditing the production environments? And that's another way to test is, let's say I've configured, my Kubernetes cluster to, have a minimum number of nodes with these pods and then a maximum number, so I don't blow the budget or whatever these things might be. Are IAC tools able to kind of help me with that auditing and monitoring piece as well of production assets?
Yeah, so I think one piece is by kind of some of the drift detection I talked about earlier, where we kind of go and pull that state back in and understand whether it's changed from the desired state, and then combining that with the policy solutions gives us the ability to sort of enforce policy against the real state. But if you want that more live, typically the cloud providers themselves have kind of policy solutions that live inside the infrastructure and can be even tighter to that, like AWS config or something like that. But the place where desired state infrastructure as code can come in really helpful there is, I think what a lot of folks do is they do interesting things where they build custom solutions for kind of testing in production, whether it's chaos engineering and really advanced kind of things like that, or it's just simple things where, hey, I'm going to run a workload against, I'm just going to be constantly running a background canary workload against my application. So that I just have some constant load and I'm able to see how that's behaving. Right. And things like that, they're not, they're custom solutions, they're things I'm going to build. They're just kind of another piece of infrastructure, but they tend to be just more IAC, right? They tend to be, here's 3 more pieces I'm going to deploy into production as part of my environment. And if I do that with IAC, well, hey, I can actually get all of that even when I'm standing up this staging environment, right? So now my staging environment can have that canary job running inside it as well, because I've described that in a repeatable way. And so we find that often these IAC tools unlock the ability to sort of build a lot more of those kind of solutions into the applications. The application kind of knows how to have its own sort of test in production infrastructure embedded into it as part of how I deploy that. And I can get that in all my different environments.
Pulumi, Terraform, the other ones that are sort of in this third wave you described earlier, how are these actually executing? Is there a runtime that's running somewhere in my cloud environment, or am I running something in a CI/CD, container, speak a little bit, because I think that kind of helps answer some of these questions too about things like audit and things like that. You mentioned a canary thing, but you're building that yourself. So how does it kind of work in that standpoint from a runtime standpoint and actual when you execute these things?
Yeah, so I think a lot of that comes back into some of these questions about, well, is it a manual deployment or is it a CI/CD deployment or is it an automated deployment? And really, at the end of the day, these ISC tools tend to be some piece of software somewhere that's running that is going to, when you ask it to change to a new desired state, is going to move you to that new desired state. That could be a CLI tool. It could be a CLI embedded in a CI/CD workflow where when I kick that workflow, it pulls out the latest Git commit and pushes me to that state. Or it could be some other more advanced workflow, like we were talking about with some of these kind of workflow engines that might be built on top of that. So really, you can embed these things into a lot of different environments, whether as just tools or software packages or services. IAC itself, I think, isn't prescriptive around that. I think it kind of depends on what the workflow is you build that into. But yeah, I think in general, we see folks moving towards those more automated solutions for sure. But they tend to be running from outside of the cloud environment in a sense, right? They tend to be modifying the cloud environment. They're sort of part of the control plane, effectively, the customer is using to manage their cloud environment. The sort of data plane of that deployment is what lives inside the cloud. And that is going to be all the various pieces. And that's sort of where I make that distinction that there's a lot of interesting things you might want to build to put in that data plane, right? You might want to build this canary deployment into your actual cloud deployment. You might want to use some of the AWS services for security and compliance, that sort of thing. So I think you kind of have those options to use IAC to describe that, but also the options to, during that deployment process with your IAC tool, enforce policy and those sorts of things.
Well, this has been a fascinating exploration, I think, of IAC. And I want to wrap up by asking you a more future-looking question related somewhat to IAC, but also more broadly. How do you think cloud tools are going to shape the future in what we hope will soon be a post-COVID-19 world? The economy is changing, the world is changing. So how are cloud tools and maybe IAC specifically, what do you envision them doing over the next 5 to 10 years?
Yeah, obviously, the last year and a half or so have been absolutely abnormal in a lot of ways. But one of the things that, you've just seen as a consequence of everything that's been happening has just been kind of every organization realizing how important software is, how important the cloud is to their business, and how much leverage that they can get for continuing to have impact with their business via software and via the cloud. And so I think the first part of the answer to this is I think cloud is going to continue to be just an even more significant factor in how organizations are investing and building for their future. Everyone who didn't already believe that has been taught a lot of new lessons about how important that is. But even the people who really did believe it are just realizing the scale at which they can get value out of the cloud.
Absolutely.
And how that can drive their business. So I think that's the backdrop for it. And then I think these tools, been maybe a little bit of a broken record on this, but I think one of the things that, I just see over and over again is that as you want to take advantage of the cloud, you want to take advantage of these building blocks that really are incredibly valuable. Getting all that value out is going to require building more and more complex solutions on top of that. That's a good thing because those complex solutions, the more complex that is, means the more value you're getting. But now all these tools have to come and take up the burden of how do we manage that complexity? How do we build software engineering teams that know how to manage very large amounts of complexity in the cloud? For companies that are really going to lead their industries in how they take advantage of the cloud, they're going to be bringing in these engineers who are able to manage the cloud at scale and build at scale solutions on top of the cloud. And I think that's where cloud development tools generally and ISC specifically are going to play important roles in helping those teams to continue to build amazing things that take advantage of everything in the cloud.
This episode of SE Radio is exclusively sponsored by Linode. Linode makes cloud computing simple, affordable, and accessible. Whether you're working on a personal project or looking for someone to manage your company's infrastructure, Linode has the pricing, support, security, and scale you need. With Linode, you get consistent and predictable pricing across 11 global markets, 24/7/365 human support, rich documentation, and policies and controls to strengthen your overall security posture, allowing you to grow at your own pace. Users consistently rank Linode as one of the leading public cloud providers on both G2 and TrustRadius. Want to learn more about infrastructure as code and Terraform? Visit linode.com, that's LINODE/SE Radio, and download their ebook Understanding Terraform and other resources for free today.
Well, Luke, if people want to find out more about what you're up to, where would you send them?
Yeah, I'm Twitter at Luke Hoban, GitHub, github.com/Luke Hoban. Feel free to drop me a note in either of those places. And of course, everything we're doing at Pulumi.
Great. So all the familiar places. All right. Well, thank you so much for joining me today on Software Engineering Radio.
Likewise, great to be here.
This is Jeff Doolittle. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.